All right, so I'm going over plotting points on the rectangular coordinate system, and this is probably going to seem pretty simple, but I'm going to be showing the technology that you can use, and we're going to start graphing on the fourth assignment for this week, and then once you hit week 5, week 6, week 7, week 8, there's going to be graphing. And so it's important to know how to do it by hand, but also it's important to know how to use the technology because that will really help you out in the next 4 weeks. And I encourage you to use the technology. So what I show you today, you're going to want to bookmark so that way you can kind of get used to using it. So the rectangular coordinate system, this is what we use to graph. It's also called the Cartesian coordinate system because it's named after Rene Descartes. It's called rectangular because if you have like a point and you draw lines, so let's say I have a point like right here. If I draw lines to where it hits, it basically forms a rectangle. So this horizontal is called the x-axis. And then the vertical is called the y-axis. And so together we call these axes. That's plural with an ES. And we're basically, determining, we have a point or a dot basically, and we always reference that point based off of an ordered pair. And it's always your x value and then your y value. So it's always alphabetical order there. And so you're basically kind of reading, visually taking your eye and reading, okay, where is it above on the X? That's the X number. Where is it across from on the Y? That's the Y number. The middle point where these axes intersect is called the origin, and that's considered the 0 point. So that ordered pair is 0, 0. So we've got this graph that's split up into 4 sections. And we start with the top right because that's where both the X and the Y are positive. So that's called quadrant 1. We use Roman numerals for that. And so you can see that it has plus plus. It's just indicating that the X value is positive, the Y value is positive. So like the X, if you move left on the X, you're going negative, right is positive, just like the number lines that we've worked with. And then on the vertical, up is positive, down is negative. So if you think in terms of like sea level, when we talk about below sea level, we're talking about negative numbers, and so positive is above. So quadrant 1 is where all of our numbers are positive. Then we move counterclockwise to quadrant 2, and that's where your X is negative, but your Y is positive. And it's this convention because that's normally when you have like real situations, that's kind of how you end up being, your X is positive or negative. Then we go down to the bottom left, which is quadrant 3, where both X and Y are negative. And then the last quadrant is quadrant 4, X is positive, Y is negative. So that's just our naming convention. We go counterclockwise. And if you have to go on to pre-calculus and do stuff with trig, that also goes counterclockwise. So just keep that in mind that we, for whatever reason on the graph, we're going kind of the opposite of how a clock goes. So when you've got a graph, in real life, you don't normally see that kind of graph. You'll see something with numbers and years, and we're usually only in quadrant 1 when we're looking at stuff in real life. And we're just graphing real data. You see a lot of things in the news that maybe there might be a graph. And we like to graph this stuff because it's just a lot easier to visually see the pattern of what's going on versus just seeing a table of numbers. Because if you see a table of numbers, you might be like, oh, they're increasing, but you don't really know if it's increasing roughly the same amount every time. But if you plotted it in a graph like we see here, you can see that it's kind of increasing steadily, so you can see more for a graph. And when we're dealing with graphs, and there will be word problems going forward where you're going to have to understand graphs and all that kind of stuff, your horizontal, the X, is always your input value. And then the vertical is always the output. So when we connect this, we can connect this to science, because in science you talk about independent and dependent variables. So the input is always the independent variable, which is roughly the thing that you don't really control. Like if you're looking at data over time, like this graph is over years, you can't control what year it is. You know, you don't really have control over that. So that's why it's called the independent variable. Time is always input. So I've seen people where they're given ordered pairs where years is one of the sets of data, and they'll put years vertically, but or they'll put it as the Y. That's not correct. Time is always the input. It's always the horizontal, because that's independent. The output is called the dependent variable, because you can control them based off of what your input is. So when I say these are the numbers that you don't control but rather observe, so you can control them, but most of the time you're observing what's happening based off of the input. So it depends on what your input is to what the output is. So that's why it's called the dependent variable. So, you know, if you're looking at data across years, the actual data you're interested in is always going to be the Y. And the horizontal, the input, is just how you're keeping track of it, essentially. So just important stuff to know when you're going to be doing word problems is that we always have our horizontal as time, and then the actual numbers and data that you're interested in is generally the Y value. So this is basically the same thing that I did. You know, I kind of talked about this when I had the Cartesian, you know, the rectangular coordinate system there, and I was talking about the axes and everything. The points that we use are called ordered pairs, and they're out in alphabetical order. And we generally, when we plot them, we usually do the X first and then the Y. So you move left or right from the center, and then you move up and down from there. And sometimes you have to kind of estimate where you're at. So if you're given like a decimal for your ordered pair, you have to estimate. So like the -1.5 comma -2.5, you don't have tick marks for those numbers. So you have to know, you know, understand 0.5 is half. So you have to kind of estimate where that falls in between the tick marks you do have. And that's probably where people struggle the most. And in ALEKS, there is a homework problem where you do have to graph some decimal values, and you have to estimate where they fall. And that's usually where people are off, because they have a hard time knowing where that decimal is. So we will kind of talk about that later. So it's good to understand how to do graphing by hand, because that's what I'm going to be, you know, when I'm teaching, most of the time I end up doing it by hand. But we're also going to be using technology to do it. But nobody ever really teaches how to graph by hand anymore, which I have noticed cause problems, because then people don't really understand how the graph in ALEKS is created, you know, because you've never had to create it on your own. So this is just the steps. You know, the first thing you draw your axes. And ideally graph paper, because you want them to be straight, or using a ruler. But, you know, if you don't have graph paper, you do the best that you can. So, like, I will kind of demonstrate these steps right here. Whoa, I don't know what it was going on. So I don't have graph paper, so I just have to estimate that I am straight. And so it's always good to label them, just so you don't, you know, get confused. So you label them, and then you draw your tick marks. And so you want to make them equally spaced. If they are not equally spaced, my pen does not want to draw. There we go. You know, you need to have the same spacing going horizontally, and then the same spacing going vertically as best you can. If you don't have them evenly spaced, your graph could have a misleading shape. And so You want to make sure that they are equally distant as best you can if you're doing it by hand, so that your shape is actually accurate. Now the horizontal, like the spacing for the horizontal tick marks does not have to match the vertical, but within each axis they do have to match. So I can't change my left tick marks to be farther away than my right tick marks, but I can make my horizontal ones farther away than my vertical ones. That's fine. I usually try to make them the same in both directions, but you're not required to do that. Then you need to pick your scale, which is basically what are you counting by. Most people count by ones, and because that's just easy enough, but sometimes, you know, you may not have room on your graph by hand to count by ones, or sometimes if you're dealing with decimals, you may not want to count by ones. It might be easier to count by 0.5 or 0.1 or something like that. So the general rule is, let's say I have to graph the number 10 for x and then 6 for y. So let's say I have to plot the point 10, comma 6 on my x and y. And I need to make sure that I can count up to 10 on my x. So I've only got 4 points here on my x, 4 tick marks in the positive direction on x. So what I would do is I would do 10 divided by 4, which gives me 2.5. So I could choose to count by 2.5, so that way I can for sure get 10 on my graph. And if it's like a nasty decimal, you might want to round up, like I could choose to count by 3 instead. But if I count by 2.5, you do want to label. You only really need to label the first tick mark because it's assumed that the rest of them are going to count by the same amount. But it may be, you know, when you're counting by weird things, it might be a little more difficult. So then you might want to label each tick mark. And then if you have to go the same distance in the other direction. So then I'm also going to label a negative 2.5. And then say, okay, I need to make sure that I have 6. So I only happen to have 3 tick marks here on y in the positive direction. So 6 divided by 3 is 2. So I'm going to count by 2's instead. So 2, 4, 6. And this will make sure that you have room to count all the points that you have to do. Because if I started counting by 10s, then I can't fit it on my graph. So it's important to pick your scale and make it something that it's easy to graph. And they don't have to match in either direction, but you do have to be consistent. And then it is good to label in each direction. So I'm also going to label 2. Now these are kind of squished in because it's, you know, I'm sketching it and it's kind of squished in there. And then you graph your points. So I'm at 10 on the horizontal, and then I'm kind of eyeballing and trying to line it up with 6 on the vertical. And so that's how you do it by hand. You have to kind of, you know, make some decisions on what you're going to count by when you're making your own graph, and it's based off of, you know, how big did you make your graph? Are there any questions on how to, you know, create this graph by hand? Okay, so we're going to just practice this. So, and this is very, very similar to the problem that you'll have in ALEKS, except that you'll be, you know, putting on their system. But you're going to have to graph fractions, decimals, things like pi, square roots. Like, how do you graph this on what we have? So in ALEKS, they'll give you the scale. But here we don't, all I have is a blank graph, and I need to figure out what am I counting by? What is the easiest way for me to count on this graph? So with fractions, when you're graphing, it's usually easier to convert them to decimals. So the 5/3 and the 7/4. So 5/3 is 1 and 2/3, or 1.666 repeating. So I'm going, well, not 6. I'm going to just round that And since we've got decimals with 1 decimal place, I'm going to round it to 1 decimal place. So that's about 1.7. And then 7/4, 7 divided by 4, you get 1.75. So I'll just leave it at 7.5. Maybe I'll change this to 6.7 just for now. But you want to kind of convert it to a decimal so you have a better idea of where it falls, because it's a lot harder when if you convert it to a mixed number, that's fine. But when you look at it as improper fractions, it's hard to graph improper fractions. Just easier to put in a decimal form. So then we've got some decimals there, and then we've got pi. So obviously pi goes on forever, so we're going to round it, and that's usually 3.14 is where we round it. So I'm going to just rewrite that in its decimal form. And then I've got the square root of 5, so I have to do that on my calculator. And then I'm going to round that to 1 decimal place. It comes to 2.236067978. That's 2.2 if I round that. So I'm going to just use 2.2 there. So now I have to decide how I'm going to label this. So let's look at the x. And I want to look at what is my largest x value that I have. I've got -3. And you could ignore the negatives because we're just looking at distance away from 0. So I've got -3, 1.67, -1.2, 3.14, 0, and 2.2. So 3.14 is actually the largest distance from 0 I have as far as the x goes. So I need to make sure that I can at least go up that far. And then I need to count how many tick marks I have in one direction. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I've got 11 tick marks. So what I would do is 3.14 divided by 11, which is going to give me a nasty decimal. It's 0.285454, and it just goes on. So let's say I just count by 0.3, because I can just count by anything. So I'm just going to count by 0.3. And so I'm going to just kind of label my points as best I can. And because I don't really have room, 0.3, 0.6, I'm going to just label every other one. 0.6 plus 0.3. So if I label every other one, that's 0.9, 1.5, 2.1, 2.7, and then this comes to 3.3, and then it's going to be the same in the other direction. Then so I should really label -0.3. There we go. Now we need to look at the y value. So I've got -4, 1.75, 3.8, -5, 4.5, and 0. So -5 is the furthest from 0. So I really want to look at like a distance of 5. And I need to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 11 tick marks again. So if I do 5 divided by 11, that comes to 0.45. So let's just count by 0.5s. So I'm actually going to move this -0.3 underneath so I can count. And I'm going to just change colors here so I don't get confused on which one's horizontal and which one's vertical. So the first one, we're going to count by 0.5s. So then this is 1, and then I can just count every other one and do the whole numbers. And then I need to go in the other direction, so that's -0.5, -1, -2, and so on. So this is sort of a lengthy process to graph by hand, but this is how you do it to be accurate. So once you take the time to figure out your system and everything like that, now you actually start plotting the points. So I'm going to do those in a different color. So I have -3 -4. So I have to kind of count over based off of what I'm counting by, and then you have to estimate, because you're not going to be able to get -3 exactly on the graph. Maybe let's see, this is -3.3. -3 actually does end up being right here. So we do happen to have -3 right on our graph, and then -4. So that's -3, -4. So I need to move horizontally and vertically and make sure I'm lined up. And that's our first point. Second one we're graphing is 1.67 and 1.75. So I'm going to have to round. So 1.67 is, so I've got a 1.5, and then this next one is 1.8 because we're adding 0.3. So it's somewhere in between those. So you kind of need to guess where it's at. And then 1.75 is kind of roughly, it's going to be there because we're halfway. 0.75 is halfway between the 0.5 and then a whole. So I'm estimating that's where 1.67, 1.75 is. You're just kind of doing your best, and it doesn't, it's not going to be exact or accurate because you're doing it by hand. Then we've got -1.2 and 3.8. So I need to figure out, okay, -1.2. So that's -0.3, -1.9. -1.2 actually does end up lining up on one of our dashes. And then 3.8. So I'm going to have to estimate, try to put it a little bit closer. It looks to be about at the 1.75. It's, you're estimating, it's kind of close enough. So you're just kind of drawing your dot there. Then we've got the pi and the -5. So 3.14, I'm going to have to estimate. This is 3 right here, and then -5. So just kind of estimating somewhere in between there. Then 0, 4.5. So 0 means you're not moving left or right at all, and you're just at 4.5 vertically. So that's going to be right here. And then we've got the square root of 5, 0. So I'm rounding to 2.2. So this is 2.4 right here. So I'm sort of kind of in between those, and then 0. So I'm roughly kind of there. So this is how you plot something by hand. And it is obnoxious, but this is what they did before technology. You had to create your graph, you had to figure out what you were counting by, and then you had to basically kind of estimate where each point falls, unless you happen to make your graph big enough that you count by like 0.1 or something like that. Are there any questions? Okay, so let's use technology. Oh shoot, this is not going to load for me. Sometimes this doesn't want to load. And this seems to be, let's see if I can refresh this and get it to load up. Okay. All right, so this is a website called GeoGebra. So it is, oops, GeoGebra. It's a combination of geometry and algebra together. So it's a website that you can use to graph. And so I've got this thing kind of embedded in here. Hopefully this works. Good. Okay, it's going to work. So it's a website that will do graphing for you. Now this is kind of, you don't see the full screen because it's sort of embedded here, but you've got the graph here and we can kind of click and drag to move it around. And then you can type in here. And normally there's a keyboard at the bottom, but it's just, not showing up. But you can use your regular keyboard. So to use technology to graph, you just literally type in exactly what you see. So we've got, and these are the same exact numbers that we just graphed. So I got a parenthesis, and you can see that it automatically closed it for me. And then -2, -5. And then, so I can click on my graph, and you can see, there we go. It's plotted it for me, and it's even given it a name. So then if I want to graph a second one, I just click in the box below, I put in my parentheses, and then to do a fraction, you use the /. It's the same shortcut that you can use in Alex. Actually, these numbers are not the same as the last one. I thought they were. They're different from the ones we just did. So this one's 9/2, 7/3, and so it does give you the decimal approximation, and then I can click and drag, and you can see that it plotted it right there, and you didn't have to worry about, okay, where exactly is this located? So next one, -3.6, 2.1, and 3.6, there it goes, point C. And then we've got 5, and then I think you can just literally type in the word pi and see it knows. So even though it's got a symbol, you just type in the word pi, so it's not PIE, the symbol is PI, and it's rounded it to 3.14. But there you go, and then you can see when I clicked away, it converted it to the symbol. So that's really nice. You don't have to, actually figure out what the number is. You just type in the word and it will do it for you. Then we've got 3.4, 0. So you can see that's right here. That's point E. You can see that it's labeled. And then we've got, there we go, 0, and then to get a square root, the shortcut is usually SQRT, and then I hit a parenthesis, and then it turned it into the symbol. And then I can put in my number. So SQRT. So, oops. Let me go back to my pen. SQRT, and then even if you hit spacebar, it will be fine. That's how it converts to the symbol, and then pi is PI. So that was 0 square root of 3, so that's here at F. And then you can zoom out here to see all of the points on your graph. So this is one graphing website, GeoGebra, that you can use, and it's nice. I like it because I can embed it into, a PowerPoint, assuming that it works. There is another website called Desmos, and I've shown this one before when it comes to the scientific calculator portion of Desmos. It also does graphing. So the scientific calculator is down here, but it's known for its graphing. You can just literally click graphing calculator. And then it looks much of the same. You input here, you've got your graph here. You can zoom in and out right here. You can click and drag. Things like pi. So if I wanted to do the one where it's 5 -pi, it works the same way. Same shortcuts. You just type in PI and then it converts it for you, and then there's the location. This Desmos doesn't label them automatically, but you can type in a label. And if you don't type in anything, it will give you the ordered pair. Otherwise, you can name it point B if you want. If we wanted to do the square root 1, 0, and it's the same shortcut, SQRT, and it makes you the square root. So And in that case, it will use a label of a decimal, so it rounds it. But it works the same as GeoGebra. Basically, if you wanted to change colors, you click and hold, and then options will come up so you can change the color of it. You can change if it's an open or an X, kind of how you want to be able to do it. So you can do some options there. And just like in GeoGebra, GeoGebra had like below it, you know, when you started typing in, it had a keyboard that we couldn't see because it was embedded in PowerPoint. But this also has a keyboard right here too. So it has a square root button, it has a pi button, it has exponents. But you can also use the keyboard shortcut to do that. So I recommend using this website. It's good for checking your work to make sure that you've got things in the same in the right location, and it will just be it'll be more handy starting in week 5 than necessarily this week, but it's good to understand how to use it and just bookmark it because we will be doing a lot of graphing. So are there any questions on either Desmos or GeoGebra? So if I type in, it's just www.geogebra.org. So it's not a .com, it's a .org. And so that one you just do start calculator here. And so it's going to give you this little different thing. And so why is that not clicking? That's weird. Oh, it seems to have frozen on me. There we go. Okay. So there you go. You've got your graph, and then this is the thing that it was kind of cut off on the PowerPoint. But they also have, you can put a table of values, and then it's got a whole bunch of geometry kind of things, doing angles, stuff like that. So that's why this is good if you ever have to do geometry stuff, because it's got those types of things as well. So I'm going to make sure this says geogebra.org. Oops. It really does not. There we go. Make that if it would, okay, well, erase. I've been having problems with my pen lately. I think the battery's died. I think the battery did die. Okay, let's see if I can use my keyboard. GeoGebra.org. Okay. Yeah, because I think, oh, now my pen's working. Okay, I don't know what's going on with my pen. Okay, so now moving on to Alex. You know, I mentioned that you have to graph in Alex. So this is what the graph is going to look like when you're doing this in Alex. It is going to automatically be, let's zoom in here. So they're going to count for you, and they're going to have these little tiny tick marks. And so you have to count how many tick marks there are here to get to 1 so that you know what you're counting by. I think it defaults to 10. So basically every little tick mark is a 0.1. When you're graphing in Alex, you're going to use this pencil to plot. So you have to kind of line up the point across where you want it to. And it does not let you go in between the tick marks. So if you're given a number like pi, you need to round it to 1 decimal place and then graph it in terms of 1 decimal place. So pi would round to 3.1. So you're going to go to the first tick mark here after the 1 if you had to graph pi on the X. So that's how this works in Alex. And it does snap to grid, so you can't go in between. And then if you mess up, you can hit the erase. So you have to be kind of careful. And if you need to kind of zoom in on the Alex graph, you can, I think, hitting Control and then a scroll wheel will zoom in for you, and then you can do that if you need to. Okay. So now we're going to move on, now that I kind of showed you that technology. Identify in which quadrant or on which axis the following points lie. So this is testing your vocabulary basically, knowing, where is it. So it's nice to just graph. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. These are positive, positive, negative, positive, negative, negative, and positive, negative. So you can use the second slide that I had where I had the picture, or you can kind of graph it yourself. So our 9, 11 is a positive, a negative. So you just kind of look at your chart and then you're like quadrant 4. So you're just literally looking at, whether it's in one of those locations based off of the signs. Now 0, negative 6.7. If the x is 0, oh, my pen is not working again. Okay, if x is 0, well, there we go, then it is on the y-axis. I'm going to use my mouse now since my pen is there. So it's not in a quadrant because it's on one of our horizontal vertical lines. Then we've got a negative and a negative. So this is quadrant 3. Then we've got negative 63, 0. So in this case, our y is 0, which puts it on the x-axis. So whatever number that is not 0, when you have one of them is 0, whatever, if the x is non-zero, so it's on the x-axis. Then we've got negative 2, 4, so a negative and then a positive. So that's quadrant 2 based off of our picture. And then we've got 10/3, so that's an x value and then a y. So this is another one that's on the axis, and this is on the x-axis because the y is 0. So the only value we have is x. Any questions? Okay. So here lists the ordered pairs that are shown on the graph. We're not going to do every single one of these. We're not going to read off every point here. We're just going to do a few. So let's look at A. So point A is right over here. And so when we read it off of a graph, you read the x value first and then the y. So the x, if I travel down to the x-axis, is in between -4 and -6. And it's halfway, so that's going to be -5. And then we are on the y, we're at 4. It's actually labeled. So you always read the x value first and then the y value. Let's see, what's another good one? Let's do C right here. So C, if you travel down, you basically go down to the origin. You're not moving left or right. So that's at 0 for your x, and then it's at 2 on the y, because that's what where the number is labeled. If we look at F, so F is on our X, we're labeled at 2, but now we're not moving up or down, so that's 0 for the Y because it's actually on the X-axis. And then let's do M over here. So M, when we go down, is at 5. It's halfway between 4 and 6. But when we move to the y, we have to kind of do some more guessing there. So this is 1 based off of what we've got labeled, because if 2 is 2 tick marks, then that's going to be 1. So our m is about roughly halfway. Oh, there's a really bad straight line. But it looks to be about halfway between 1 and 2. So you would estimate that at 1.5. And you're not going to know exactly what the ordered pair is, but you put in an estimation. And a problem like this, they're not going to give you something like, oh, it's not, you know, it's not 1.5, it's 1.478. They're not going to do that on you. You know, they're going to basically do it to like 1 decimal place. So you just kind of estimate where it's closest, and it's about halfway. So that would be 1.5. So that's how you read off of the graph if you're given a graph, you know, and then you have to kind of go the other way. We practiced creating the graph. Now you're given it, you have to read it based off of the labels that you have. Any questions? Okay, so my last 2 are actually word problems, just to help you read a graph that you might actually see, you know, in the wild, in the real life here. So we've got a graph that just shows the percent of students in the College of Engineering at some university going from 1950 to 2000. And so you're trying to read, what does this graph mean? Just at a glance, obviously you can see that there's more students going into engineering over time, because that's, you know, it's increasing. So part A, approximately what percent of the students were in the College of Engineering in 1990? So you have to go to where engineering is in 1990, find the year, and then kind of approximate where is that actual point at. So 1990 is at least labeled on X, and now I just kind of put a dot on the line where it seems like that is, and then you have to kind of estimate. So it's obviously less than halfway, because halfway is about there. And halfway between 27 or 25 and 30 would be about 27.5. So it's less than that. So maybe it's at 26.5, 26%. You kind of have to approximate. You have to estimate what that number actually is. So let's just, you know, say maybe about 26%. Maybe you think it's closer to 27. Actually, I think it might be closer to 27. So let's say it's about 27%, maybe. Either way, you just have to kind of guess when you're looking at a graph like this. That's the downside of graphs, is you don't know the actual numbers. All you have is the graph, and you can't get the exact data. You just have to see kind of where it's near. And then part B says what year corresponds to 15% of the students being enrolled in the College of Engineering. So you're kind of going backwards. You're like, okay, 15%, where am I hitting? Okay, that's right here. And then you go down, and that's 1980. So it's just a matter of knowing which direction are you going, what numbers are you looking at, and making sure you're reading the graph accurately, you're doing your estimations kind of correctly. I think the estimation part's probably the hardest for most people, because you have to kind of, you know, I usually work in halves, and that kind of helps me out figure out where it's at. Any questions? Okay, so last one here. So we've got another graph. The graph below shows the hourly temperatures recorded over the course of a day. And one thing I want you to note is you see this little thing right here. It looks almost kind of like the graph was ripped. We use that zigzag to indicate that we're skipping 0 to whatever. So instead of actually doing our graph and starting at 0, where we have no data, we're starting from 72 instead. So like this is still 0 down here, but we're just skipping everything between 0 and 72 because we don't have data there. So that's something that you'll see, because it's just like you're kind of ripped off that part of the graph because we don't really need those numbers. So that's just what that little thing means. So I'll let you guys participate in the chat for this one. What was the temperature recorded at 5 p.m.? So you can just read the graph and then tell me what it is based, in the chat. Or maybe you guys are shy. I'm not seeing anything in the chat. That's okay. So 5 p.m. So that's right here. So I just need to read up, and that's going to be, there we go. Okay, you both came in 76. That's correct. So, and my pen just decided not to work again. Try this again. I'm gonna have to change my battery after this. 76 degrees. Okay, so this one's a bit harder. At what time was the temperature 75 degrees? So 10:30, that's good. Yes. So, 75, you have to read the graph, and that's about right here. And then you're like, okay, that's about halfway between 10 and 11, so that would be 10:30. Okay. And then what it was the maximum temperature observed? 79 at 1 p.m. Yep. So the maximum temperature was 79 degrees, and then, okay, I'm trying to use the @ symbol. That was not very good, but because I'm trying to use my mouse since my there we go, something like that, at 1 p.m. So, because that's highest one right up there. So there we go. All right, very good. So that's the basics of the rectangular system. Really being able to read the graph and understand what the numbers mean is going to be very important as we move forward. We'll be looking at whether things are increasing, decreasing, how much are they increasing by. We're really going to be looking at what the graph is telling us. Is it increasing faster than in one direction than the other direction? That sort of stuff. And, bookmarking either GeoGebra or Desmos. Definitely take advantage of those websites. Use them to make your life easier. You're welcome to use those on quizzes. So, don't forget that these exist, because it will save you a lot of time. So, you guys have any questions? All right. Well, then we are pretty much done. I know normally if I have extra time, I will go over other questions, but we've only got 10 minutes and I still have to finish grading. So I want to make sure I get that all done and everything before the weekend. We have, let's see, Grantham, like all employees have Monday off because it is Labor Day. So just an FYI, I will not be regularly at my computer. I may be occasionally checking email or popping in to like do some discussions, but I'm not going to be spending like my whole day at the computer on Monday. So just an FYI about that. And I've got a busy weekend just for Labor Day stuff. I've actually got a wedding reception to go in with people in town, so stuff like that. So this weekend, I may be less available than I normally am, but I will try to answer any questions that I get via email and stuff like that. But I just wanted to give you guys a heads up. So, all right. Well, thank you guys. Next week should be normal time. So this should be just a one-time change. I think 2 weeks from now, I will have to change it again because my dad's going to be in town. But I'll let you guys know what time I change it to. I think I might make it like a Sunday instead or something like that. But next week we'll be back to Sunday at 1 p.m. So that will be back to normal. So Saturday at 1 p.m. Don't want to confuse you guys further. Okay, well, I will let you guys go, get back to your day. I hope you guys have a wonderful Labor Day. Thank you for coming. I'll get the recording out today and everything. And yeah, I'll talk to you guys later. Bye.
Thank you. Have a good weekend.
You're welcome. You too.